basically the title of our talk today is National Wetlands Inventory, New Data for Sage-Grouse Conservation. And I thought I'd start off with an overview of the National Wetland Inventory program. I don't know how many people are really familiar with NWI in Nevada. Probably a lot of people haven't really used a lot of our data here because it's very old, and I'm going to talk a little bit about that in a little while. But so basically our vision for NWI is to provide current scientifically based information on the location, status, extent, characteristics, and functions of wetlands and related habitats to promote the understanding of conservation and these resources. We basically have two main functions that we do. The first one is to serve, to create and to serve data to the public. We do that through our wetlands mapper. This is a little screen capture of what the wetland mapper looks like. Just this past year, we actually accomplished reaching complete digital data for the entire country for the lower 48, and then we have 40% in Alaska of digital data. So we just celebrated our 40th anniversary last month out at the National Conservation Training Center, so that gives you an idea of how long the program's been around, how long it took us to achieve that full layer of digital data. The second priority that we have is to create the National Status and Trends reports to Congress. These are a couple of the older ones we've done, and we just recently had another one come out that's 2004 to 2009. And the function of National Status and Trends is to really help out with policy and decision making to keep an eye on what's really happening with the wetlands in the country. And most recently we've started to do a coastal report that comes out of our National Status and Trends plot. So those are our two main functions for our program. The next thing I really wanted to talk about was our wetland classification standards and our riparian standard for people that aren't familiar with these. One of the things about getting the Federal Geographic Data Committee standards in place is that it ensures that all of federally funding for wetland maps comply with the standards. And that really helps drive updates to be compatible with the wetland mapper and being allowed to input data from other sources into the maps. So people can actually create, like the state of California has created quite a bit of data that's outside the standards. They don't use our classification system, and they don't use, but they use a lot of our delineation standards. And then we've developed crosswalks so that they are able to put their data into our national mapper. So it helps us update areas that we otherwise don't have funding for. NWI is one of those programs that is pretty much underfunded, and the last couple of years we actually have had money to support our staff, but have not had the funding to support any mapping projects. So most of our mapping data money comes from outside sources. So I'm sure people know a lot about wetlands if they're on this talk, but I wanted to make sure I define something that I've run into quite a bit in working with BLM and other agencies, is that when we talk about wetlands and riparian areas, most people think of riparian as being the same as the wetland corridor along streams. But for the purposes of mapping in the National Wetlands Inventory, we've had to create two separate standards. So our first standard is the wetland mapping standard, and the definition that we use for the wetland mapping standard is basically this. It says wetlands are lands transitional between terrestrial and aquatic systems where the water is at or near the surface of the land. So basically that's saying you've got, if you know wetlands, you have three parameters for wetlands: hydrology, soils, and hydrophytes, plants that can live in wet conditions. And so for the purposes of wetland mapping, we first have to have the water. And then after that, we have to, at least periodically, the land has to support hydrophytes. So that is found from the National List of Plant Species. The second thing, so it says or, so one or more. So we don't have to necessarily have all three parameters to map because it's a remote sensing project, but we do try with vegetated wetlands to reach all three parameters. It is our goal. So the second goal would be the substrate is predominantly undrained hydric soils, which we get through the hydric soils list and SWCA soils data. And then the last thing is substrate is non-soil and is saturated with water or covered by shallow water at some time during the growing season of each year. And this, in the mapping world, allows us to map things like beach bars, beaches, rocky shores, gravel bars along a river that wouldn't really be considered a wetland, because the classification system does cover wetlands and deep water habitats. So this is the classification system. We call it Cowerden, after Lou Cowerden, who's the primary author. And it's a hierarchical system that goes from systems, which are general, riverine, lacustrine, palustrine is what you would have in Nevada, down to subclasses and water regimes. So the water regimes will tell you how often an area is flooded. And then we also have special modifiers that allow you to talk about man-made influences or even beaver. I'm not going to go too far into the classification system. I'm just trying to give a general idea for people that maybe aren't familiar with it. So basically the systems that you'll have in Nevada are the three bottom ones, riverine, lacustrine, palustrine, which covers all the freshwater wetlands, and subsystems and classes. And then classes basically separate out the vegetated from the non-vegetated type of wetlands. And so we actually have a different definition for riparian that might be, that we developed because we were running into areas that really didn't have hydrology. So we really couldn't map them as a wetland in our wetland maps, but people wanted them on the maps because they're critical habitat for many species. So we ended up developing a riparian definition in our riparian classification system to actually map the upland portion of riparian. And I wanted to point this out mainly because when I talk riparian, it might be different what you're thinking riparian. Because a lot of times people think of riparian as being both the wetland and the upland portion. And it is, but just for mapping purposes, we've separated it. So basically our definition, plant communities that are contiguous to and affected by surface and subsurface hydrologic features of perennial or intermittent lotic or lentic water bodies. So they have one or more of the following characteristics. They're distinctly different vegetative species in adjacent areas, or they just are showing more robust and vigorous growth because of their adjacency to water. And this is that's a really bad picture, but this is our system for mapping riparian areas in the western United States. And it's a simplified system subsystem class. We kind of kept it the same. We do allow dominance types. So it's basically would start off with a coding little RP instead of some of our regular codes, and gets down to further detail. So I just wanted to separate out that for people that maybe aren't familiar with NWI mapping and the fact that we kind of have a different definition than maybe what you're thinking. So now I just wanted to move on to status of mapping in wetlands. And I just realized I didn't mention that this is going to be a two-part talk. So I'm going to kind of talk about the status and the history, and then I'm going to turn it over to Chris Moller, and he's going to show some examples of the work we're doing now and talk a little bit more about methodology also. So, so this is just more general. Currently, this is the top picture shows an old blue line copy of an old map. That was pretty much what we had until recently for big sections of, in fact, this brown area in in the map here, the big brown area is what's 1 to 250 scale data, and the lighter brown area is actually still just, we have these existing hard copy maps like these. So just to go through what, like the data that's available in Nevada now. Most of the data is from the mid-'80s, as you can see from this diagram. There's very few areas that have more current data. The Reno-Carson area has data that's actually from 1999 imagery, and that was a project that we did out here. I think we gave a training in the Reno field office here back in late '80s, and we were trying to find field sites to do our field portion of our training, and driving around, everything that we had selected was already developed. So we got this brainstorm that maybe we should do a status and trends of Reno-Carson area. So we actually had 1 to 24,000 scale imagery flowing for the area that you see in brown, darker brown on the left by Reno. And we actually updated all the data and then did a backward trend from older imagery. And did find there was considerable amount of loss occurring in this area to wetlands. So that's probably some of the more updated stuff, except for there's some blocks of green that you see that's based on, I think, 2013 imagery. But that is basically was some of the last area that had never been mapped in Nevada, and so we did what we call a scalable mapping, and I'll talk about that in a minute. So the source of data was mostly color infrared. That's mostly what we used in the mid-'80s, was a lot of color infrared, 1 to 58,000 scale. Except mostly we're using now more natural color. True color I have on there. And then the scale of the mapping, the vast majority of Nevada is this 1 to 250 scale mapping. So I just thought I'd point that out. So obviously you can see the need to really have some more high accuracy mapping done, because the national standards for wetland mapping, the standard actually requires 1 to 24,000 scale data. So most of Nevada is not even to national standards. So here's a map I'm just showing of what the polygons and the linear wetland layer of the NWI data looks like as it exists today. On the left, you see polygons only, and I wanted to point this out because currently our wetland mapper only displays the polygon data. So that's what you would find on the wetland mapper. If you look on the right, you see what it would look like if we actually added in all the existing digital linears we have, which that would be kind of more all of your riparian type wetland habitats, what you guys would call riparian, the wetland and the wetland and the upland riparian portion. But so you can see that there's a lot of data that's not even served on our mapper, and we've resolved that with our new methods where we are actually only mapping polygon data only. So we're actually buffering all of our stream data, all of our what used to be line data, and putting it into a polygon layer. So this is just a little comparison of the 1 to 24,000 scale for the Reno-Carson area and what it looks like next to 1 to 250,000 scale imagery. So you can see exactly which quads, which USGS 1 to 24,000 quads were actually done at 1 to 24 pretty easily in this comparison. So I'm just going to show like a little screen capture of the 3 different types of data that is available out here. The 1 to 250 scale data basically was derived from originally 1 to 58,000 scale imagery that was delineated, hand delineated with a rapidograph pen onto the imagery and then transferred to a map. then because the decision was made that there was so many maps that had nothing on them, that the cost to NWI to actually produce those hard copy maps and have them digital, there'd be maps that we were sending through Photoshops that were going to have nothing on them. So the decision was made to do this thing called simplexing, and they actually took another layer and put it over the Mylar and made a simplified version of the maps. And then they just drafted those over the 1 to 250,000 scale maps. So that's what you mostly have in Nevada. And when people say NWI data in Nevada is terrible, I will be the first one to agree, because it's just very old and very outdated and not very accurate. So this just shows a couple of polygons, and this is from the Wetland Mapper. If you actually click on a polygon, you can see I've clicked on the polygon that's highlighted in yellow. It'll bring you up a little box that will tell you about that polygon. It will give you its classification. It allows you to use a little button to decode that if you're not familiar with our codes, and give you the acreage and what year it was made. And then there's also links to the metadata report, which would tell when the field work was conducted and what we found in the field. So that's the vast majority of the data. Our standard is 1 to 24,000 scale, which we really only have 56 quads in the entire state that are actually to national standards at this point. So, and this is actually just south of Reno here. In fact, part of me wants to say this is the old Double Diamond Ranch area. Maybe. But you can see even this 1990 imagery, look at all the development that's happened underneath that palestrin emergent temporarily flooded polygon. That was after our study. So, and then the last thing I'll show you is in the current NWI data section is just what we did for that scalable data. And the funny thing is the scalable data was done using just a bunch of existing data that's out there. It was using the NHD data, the National Hydrography data set, the Surgo soils data, the topos, and they basically just took all those and put them into an NWI classification and served them up on the mapper. So on the left-hand side, you see the yellowish with the blue lake in it. That's actually the 1 to 250 data. And then the right is just the scalable stuff that was done using existing data that's out there. So, but what we're doing actually, you will see is what our final project is going to be is much more detailed than even what you're seeing on the right. So just a little bit about the project itself. And so one of the things that came up in the beginning of this project was talking about the need for new data. And Patrick Donnelly did a study using, was more of an automated remote sensing study that came up with this quote that said, despite encompassing less than 2% of land area, wetlands are keystone features that structure populations as evidenced by greater than 80% of breeding distribution clustered within 10 kilometers of wetlands. And that's from this Public Lands and Private Waters report that's quoted at the bottom. So that kind of got us talking about the need for more data. And so in 2014, Todd and Ted and other people started talking about it, and we developed a 5-year interagency agreement with the BLM to start this process. We'd actually had an interagency agreement with California for work we were doing on the Desert Renewable Energy Conservation Plan down there. So we just tagged onto that interagency agreement to continue this, and then we developed contracts with SWCA as the primary mapping contractor, and they've been our contractor for a number of years now, and always been very happy with their work. So, and we began by mapping the first 504 quads with updated wetland and riparian data. So the funding was coordinated by the Great Basin LCC for the project, and the funding sources were BLM and the Fish and Wildlife Service ES office also kicked in some end-of-year money last year. So we got the project started with that. And this was kind of our initial planning map when we were trying to figure out where we were going to, where the need was. So the red shows where the existing 1 to 250,000 scale data was in conjunction with the Sage-Grouse pack. And then the blue shows where we had existing hard copy maps. And then this came, the final decision, like people got together and talked about what maps should be priorities, and so these were our priority areas for the first 504 maps that are shown in red. And Chris is going to show you where we're at with that in a little while. And then there was still another 579 maps at that point that fell, that we could not fund with the existing funding, that we hope we can get further funding for to keep moving. So delivery dates, we're going to actually finish the first 300 quads by July 15th. They will then go to our National Quality Control Office, our National Standards and Support Team, to conduct national quality control. And they will be served up on the wetland mapper by the end of the fiscal year, September 2015. And then we should finish the next 204 to, I say 204 to 300 quads. And I know that's a big gap, but the way that our contract works is it's, you know, it's based on how much funding is left. So if they, you know, they are required to accomplish the first 504 and any more that they can do after that. So we're hoping for more, and I have no doubt we'll get more. Well, they always do. So then I just wanted to talk a little bit about future funding and future priority setting. So this map shows basically the first set of funded priorities in green, and then the second priority would be something that we would hope we could get funded in 2015. And then the last thing I have on here, priority 3, would be to finish the entire state with updated data. And we have developed some quad numbers and some cost estimates for that. Basically, it would take another 767 quads to complete the biologically sensitive areas. And I forgive me because I don't know the packs and the BSAs. I'm not really sure like how those coincide.
You're not the only one.
How they, if it's the same thing or a different meaning, anyway. So I kind of use them interchangeably in here. And then to complete the rest of Nevada would be another 687 quads. And the rough cost estimate for those, well, which is actually a pretty accurate cost estimate, was to complete the rest of the Sage-Grouse priority areas would be about a little over $500,000, and then to complete the rest of the state would be $440,000, and that actually includes the 6% overhead rate if it doesn't come from Fish and Wildlife Service itself, because if it's BLM funding or another agency, we have to charge that, unfortunately. So if funding weren't an issue, we would complete the wetland layer. We'd bring everything in the whole state up to date, and we'd probably like to take some new directions. There's a thing called LLWW, which is Landscape Landform Water Flow Path. And that's a thing that Ralph Tyner out in Region 5 developed, and it's actually allows you to put some extra coding onto the NWI data that gives you, if you're familiar with HGM classification, hydrogeomorphic methodology, it allows you to say where the wetland is in the landscape, what its flow direction is, like is it an inflow or an outflow, through flow wetland, and one of the things that they found creating this extra layer is that they've really been able to help address and look for areas to protect and areas of restoration potential. So, and then we'd love to do some modeling and tracking of wetland changes over time. So our next steps right now, in order to complete all the priority quads in Nevada, we need additional funding. And one thing I'd like people to think about here is if they know of other data sets that are available that would be useful to us during this project or into the future, we'd love to hear about it. And we'd also be interested in anybody that's doing field work this summer that would be interested in taking the data, even if it's preliminary data and not final, to give us feedback. So I'm going to actually I have a question slide in here, but I think we'll hold questions to the end, and I'm going to turn it over to Chris Moller from SWCA now to do his section.
For folks on the phone, we'll be taking questions at the end of the webinar, and you can type them in the chat box, and we'll have them read out, and then we'll have each of the speakers answer them as we go.
Hey everybody, my name is Chris Moller. I work for SWCA. I work with about 5 wetland mappers who've been working on NWI mapping for the last 8 years, but most of us together for the last 5. And we've been working on projects all across the United States, including California, Nevada, Oregon, Washington, the Pacific Islands, and several projects on the East Coast. And usually what we're faced with, and in particular here in Nevada, is we're faced with aged data. On the screen now is an image of typical existing NWI data that Elaine has already told you comes from the 1980s era imagery. It's 1 to 58,000 scale imagery, and the maps are 1 to 250K. They all have a general classification, meaning they don't have water regime or subclasses. There are a few riparian features that are represented and few smaller features represented, mostly because of the process that she brought up for creating these maps out in the West. And what we're tasked with is changing this into a modernized NWI data product where we have updated line work, updated classification, where the linear features that were omitted or not served up previously are included, where potentially missing features or smaller features that weren't previously mapped are included as well. The data standard, I believe, is for 1/4 of an acre. Any wetland less than 1/4 of an acre should be put in to the mapper, but I think we're currently at 1/10 of an acre and try to go as small as we can, given the amount of time and money and effort that are needed to create the data. And then occasionally, we remove features as well. I think Elaine had a very good slide where there may have been some development on a wetland or potential wetland, and it is no longer a viable wetland, so we would adjust the boundaries in that particular case. So we use a lot of different input sources for our data. We can't recreate the wheel every time we start a new mapping project, so we have to beg, borrow, and steal. And if it's not broken, you don't need to fix it. So we use our existing NWI data, and there's a lot of useful information in the old NWI classifications, despite their age. We get an idea of what past drought water regimes were, what species were there in some cases. We've got updated high-resolution NAPE aerial imagery, and we also have historic imagery, access to that we can reference for looking at the periodicity and the change in the various wetlands. We have access to NHD data, which is pictured off to the right. That mess of points and lines and polygons is one of the most complete data sets that we have to work with when we're doing our updates. We have soils data from SWCA, elevation data from the National Elevation Data Set, historic imagery that I've already mentioned, local knowledge, which is also very important, for our work, and we conduct field visits as often as we can to verify that what we're seeing from our overhead view matches what is actually on the ground. So to start with, I'll tell you a little bit about how we do our riverine updates, and we use a variety of different processes. But in addition to using the existing data, we've come up with a way to identify where there may need to be streams, augmented streams, to really complete the stream network. So we're using our existing streams as much as possible, either through the NHD or our own streams that have previously been mapped. And we'd like to typically add to those streams and or reshape the data as needed. And to do that, we have some input data sets for a partially automated process. We use our aerial imagery, a DEM, an aspect, and the flow accumulation model that then run through ArcHydro or Tau DEM or another flow accumulation type model. We get a representation of what should be there on the land surface, given what the digital elevation model tells us is being drained. And from there, we see that some of these stream selections are represented twice on the landscape. So we try to come up with a way to identify those, eliminate those, remove the similar streams or the conflated sections, and finally we're left with a complete hydrograph or network of streams that we can use to reference for our process of augmenting the streams and riverine features within our data set. And from here it goes to the individual analysts to assure that each one of the streams is lining up with the actual feature on the aerial imagery. Here's an example of some of the work that we've completed or is in process. You can see some adjusted riverine features. My apologies to those online if you cannot tell the difference between the green and the blue lines. The green lines are lines that had started out as NHD lines, and the blue lines are what will eventually become our NHD riverine features in the final product. And you can see at the bottom, towards the bottom of the slide, we have quite a bit of work to do on some of the flow patterns or flow paths because they do not actually line up well with the existing riverine feature, which is what we map to. And in the end, we've, in this particular scenario, we've actually added riverine features where we can see other flow paths that were identified previously through the previous method. And then we've also added springs and seeps or just adjusted their direction or their location. And additionally, we've added in the wetland features that had not been mapped previously. Another thing we encounter quite a bit here in Nevada is these playa complexes. And I say playa complex, they are extremely complex things to map. There are hundreds to thousands of polygons that are individual, and they have very intricate boundaries. And in addition to that, they have linear features that need to be mapped as well, going through the playa complex. This is an example of the existing NWI for the area, where in the past somebody had pulled out the larger playas and dry lakes, and you can see that it's obvious that this data is for purposes of looking at fairy shrimp or some other purpose that you can imagine for looking at the playas is inadequate. So through a process of using supervised classification techniques and some filtering and buffering and then culling of all these numerous features, we get something that is incredibly more complex in terms of the number and the resolution of the data. and then we add and reshape the riverine features as needed. Here's another example of some typical things that we're seeing. I believe this area is towards the northern end of the Nevada study area. We have some wet meadows, and this is what the NWI has previously mapped it as. There are no linear features. There are no wetlands present whatsoever. But you can see in the photos that there are quite a few wet meadows, or what appear to be wet meadows in here. This is the NHD data that we have been using to help inform our mapping process, and you can see they have pulled out quite a few seeps and springs and other features that coincide with the wet meadows that we would typically like to map. And then here is an example of a finished product, or a product that's ready to go to final QC of that same area, where we have added in the cluster emergent areas adjacent to streams, straightened out streams, and linear features where they need to be realigned with the actual water flow path. And then we add boundaries to our springs and saturated seep sort of areas to get a good idea of what their extent is. To Summit Lake, how are we doing on time? Okay. This is Summit Lake, which was another interesting area that we thought would illustrate our update process fairly well. You can see the Summit Lake in its false color near infrared aerial imagery, and you can see quite a bit of saturated soils, things that you would normally expect to be mapped as wetlands. And you can see a lot of emergent wetlands rimming the lake itself. This, again, is the existing NWI data that's 30 years old. They've pulled out some, the larger water body and some cluster emergent wetlands, indicating that there were, in fact, wetlands there at the time. And then here's the existing NHD data, where they've included quite a few more features. They've got some small ponds, impoundments on the water features flowing into the reservoir or lake, but they still don't have anything representing any of the wetland features that we would like to see in our data set. So using the information that we have, then we take the data from NHD, the flow lines, realign them where they need to be realigned, add in our wetland features, again, which are quite large and extensive, some of the riparian features up here, and then reshape all of the lake boundaries. One of the things that helps us when we're doing the mapping process is access to various sources of information. And one of the ways we get at that is through Google Earth. We have some tools that allow us to look at Google Earth easily and query the information from various sources from them easily. In this particular case, is a picture of Summit Lake through Panoramio, where you can click on the picture. And in case you were wondering what all of the emergent vegetation was in the shallows in the reservoir, occasionally you have a picture that confirms that, in fact, there's bulrush in the shallows, which corresponds to the imagery, and you've got some sort of grass species growing in the forefront there, which can lead to both asking questions and answering questions. If you know a little bit about your plants, you can ask or do a Google search and then find out what a particular plant is. And this particular plant, which I believe to be in the foreground of the picture, is in fact a wetland, a fact-wet plant. So that definitely gives us an idea that we are in the right direction, or heading in the right direction as far as our mapping process goes. Another example from northern Nevada is this spring complex, which I thought was pretty interesting. We've been mapping quite a few springs, and it's a surprisingly wet area given how dry it is currently. You look around the landscape, and yet you see these springs popping up everywhere. Again, the existing NWI has not mapped any springs or wetland features in this area. And here we have the existing NHD that maps quite a few springs and water features, water flow paths in the area. And then a final example of something that's ready to go to QC for our process. And unfortunately, this is one of the areas that I saw when I was putting my slides together that I missed a couple of springs. We'll have to go back and look at. But there are a few, a couple more small springs along the slopes of these mountains. So we're imperfect as well, but we try. Back to Google Earth. One of the fun things we get to do with this is the same area. We get to use this as a tool to see how things lie on the landscape. So if we have a question about where this perched line of springs on this mountainside lie, we can actually tilt the image down so we can see where they are and potentially make some different inferences about the landscape position of slope wetlands or whatever wetland we're looking at. Again, you can see a zoomed-in image of the toe slope spring here at the confluence of, close to the confluence of two streams. We can add in soils data, which helps us with information about whether or not the soil is hydric, and we can use it to go back in time, so to speak, and look at past imagery to see if something is persistent or not. Here's another example of using the soils web. And at the very bottom of the image, you can see a little man standing on a blue road, which is also extremely helpful if you can actually get street view in Nevada. There are not a lot of places out there. We've mapped some other places in the U.S. where we have a little bit more access to street view. And I'll show you a slide how we're using that later. But using the SWCA KML provided by, I think it's UC Davis maintains this in partnership with SWCA. Anytime we want to query what type of soil is present, we can use Google Earth to pull up the different percentage soils within an area and potentially get a soil taxonomy report that will tell us exactly whether or not something is wet or not and what percentages of wetland inclusions exist in there. Here's my street view photo. It's washed out, not as much as I thought it would be, but you can see salix species, or what I believe to be salix, in a desert wash, which is another good indicator of wetland species being present, but you can also see a lack of water, which gets at our hydro period, or periodicity of the flooding. How much time are we at? About 5 minutes. The rest are pretty, I'll go through them quickly. This is Pyramid Lake, and show you some updated NWI features where we're incorporating much more detailed wetland boundaries and the streams. Again, NHD, previous NWI, and our updated product. And I think this might be the last or second to last. So I'll kind of sum it up with some of the uses we found for NWI from various people we've worked with. Quite a few people use it for the landscape level planning and decision support analysis for many different types of species, especially the threatened and endangered species. It's used extensively in biological monitoring, especially for plants, and then up to 60% of endangered species live some form or some part of their life on a wetland. A lot of wetlands and refuges, so our NWI data, especially when it's up to date, is used in their conservation planning efforts. I talked about the threatened and endangered species. Energy transmission planning all throughout the western United States. People are generating and transmitting energy, and they need up-to-date information, especially for siting these new projects. flood mitigation and planning, which hasn't been a real concern for people here lately, but it is across the nation. And conversely, then drought mitigation planning. Wetlands are like wetlands turn mountains into sponges and can potentially offset some of the effects of droughts. And with that, we'll take your questions.
Elaine, why don't you come up here, speaker? Thanks, Chris. Well, thanks, everyone. Liz, if you've got questions that have been typed into the chat box, would you read those for us?
Yeah, so we have received one question that came from the first half of the presentation, and the question is, why aren't we capitalizing on remote sensing and image processing advances to improve our mapping of riparian/wetland resources? For example, 1-meter resolution 4-band imagery is being utilized to accurately map PJ and other plant communities using automated object-oriented classification techniques.
So we actually do use eCognition and a few other remote sensing pieces of software. If you look at the historical NWI data and the level of detail that you can get out of the newer information, I think there's the potential in the future that the two are going to start dovetailing more. Where I see the automated processes falling down is when they come into contact with the actual classification portion, where you still need somebody who can look at a map and put themselves on the landscape and come up with the correct classification, whether it's a Pleston emergent or a Pleston scrub shrub, and then also the hydric regime or the hydrology regime. I think it's almost there. In fact, we've seen a lot of good products coming out of Ducks Unlimited in the upper Midwest, but I don't think it's quite there yet. And technically, to be compliant, it has to go through the FGDC wetlands process to be served up. We look at, as part of our duties in Portland, we look at QCing and doing quality assurance for some of these other projects, and a lot of them show a lot of promise. And we use it to the extent that we can for areas that, like the Playa example, we can leverage it to its benefit and not have any sort of ill effects from it.
And then also, I'll address that a little bit myself. One of the things that I've been working for a number of years with the state of California is on some automated riparian classifications. And actually the way they developed it was very in conjunction with NWI data. So what they actually did was take as they updated NWI data, they created an automated process to do riparian, which used CalVeg and the slope, and they've got some automated riparian output. And one of the things that was kind of interesting about that is it's really, the way they've developed it is more of a riparian potential map rather than actually the existing riparian, because when they take into consideration the slope and alloxanous input, if a tree falls over at the top of the slope and it gets into the river, that's what they wanted to consider also riparian. So we have been looking at some of the things that are happening in other states and staying aware of them. So
I have one more thing to add to that. There is a bit of a problem in certain areas of the United States. The models that we've seen that are successful are very regional specific, and to apply them across the landscape is going to take some modification and some effort. And there are areas, unless you have LiDAR, that cannot be mapped just using the imagery and the object-based classification alone, because you can't see below the trees, which is fine if you have leaf-off imagery and you're mapping wetlands in the eastern United States. I think you can leverage that a little bit more. But if you're mapping a wetland on the coastal range or throughout the the Cascades, underneath canopy, you'd be hard-pressed to make the object-oriented classification work, again, without extensive data.
Okay.
Thanks. Liz, any other questions?
Yeah, so we've got four more questions it looks like that have come through. So the first one on here is, does this project have the capability to identify mesic meadows?
Well, we definitely would like to think that we can identify mesic meadows. We're out doing our field work now in search of these areas that we have not set foot on yet. But maybe Elaine can.
Yeah, part of the reason we're here is to do our first field trip. We've got about 180 quads with us that are done, and we're planning on heading out and looking at those. But we do have to make sure that we are mapping things that are, considered wetland when we're using the wetland classification system. And so the term, maybe I'm not as familiar with mesic meadow, and is it a drier end, I think, type of habitat, right?
There was actually a follow-up clarification that just came through. They're saying that wet meadow communities requiring water table depths during the growing season of less than 30 centimeters, whereas mesic meadow communities require about 55 centimeters, and dry meadow communities require about 120 centimeters.
Yeah, so if they actually don't fit within where they have an actual hydric soil, and I know that's probably a concern because that's one of the communities that Sage-Grouse like to use, correct? So, yeah, and I think that was one of the areas that Patrick Donnelly's work was slightly different from ours. We actually met with him in the very beginning. So yeah, in terms of the Sage-Grouse, I could see where it could be critical. We do have an ability to map.
Go ahead. Let's finish that and we'll get to
Oh, yeah. Okay. Okay, we're running short, so I'll go ahead and I'll stop there. Go ahead.
Next question, Liz.
Yep. Next one is there any way to map beaver dams in association with wetland inventory, and can Fish and Wildlife Service barrier inventory be used to determine where beaver dams are located?
Yes. We actually have a special modifier in our special modifiers specifically for beavers. I'm not kidding. Little b. It's a little b at the end of the coding.
Having said that, being able to identify the beaver dam itself and the impoundments, if there's a characteristic look, then we can definitely classify them. But having knowledge beforehand of the potential presence of beavers would be the key for us to actually map it as such. Otherwise, it would just be a palestrin emergent wetland.
Or else it might have a small impounded modifier on it if it looks impounded. So, yeah, if we weren't 100% sure it was beaver, it would be the beaver pond itself would be classified as impounded.
Great. And there was also a follow-up question about is this data, and I think it's referring to all of the data you've presented on, available, and if so, where can it be found?
Oh, okay, yeah, I actually had something on that earlier in the presentation. So all of the existing wetland data is, if you just Googled wetland mapper, the top thing will be the National Wetlands Inventory wetland mapper. But currently, we don't have any of the new data that we're creating up. This is our first trip out here, and I said the first data will be delivered to our National Standards and Support Team in July. On July 15th, it will be 300 quads, and it should be up on that wetland mapper by September 30th of this year. But if people want to do some field review with it this summer, we'd be happy to share the preliminary data. Yes.
Is there a place where we can more specifically find which 300 quads are not?
Did
Yeah.
you hear that, Liz? Do we need to repeat the question?
No, if you guys could repeat it for those on the phone, that would be helpful.
Yeah, there was a question in the room, is there a way to identify the 300 quads that will be available? Yes. Anybody that's interested can I had my email address up here. If you're federal, it's Elaine_Blok, BLOK, at fws.gov. If you email me, I can actually send you I already created a PDF quad list. And I can even send a shapefile if you'd like that, prefer that.
We can have that added to the Great Basin LCC project website. So if you go to www.greatbasinlcc.org and look at the projects, we'll have Elaine's information added to this project. We have a question in the room.
So for Sage-Grouse planning along the California-Nevada border, I wonder, it didn't pop up as a priority for funding, but going into California for the bi-state area as well as northeastern California. I wonder if you had any discussions or hopes that funds might come available for that.
Yes. So actually a lot of the, if you look at the lower tri-state area, there's actually quite a bit of updated data there that we actually did as part of the Desert Renewable Energy Conservation Planning effort. We were funded by California BLM to work out there. And so there is quite a bit of data there. And actually I've been asked by California BLM to put together another proposal for more funding this year to keep working in California. And my personal thought was give them two options, one being continue the work in the DCREP area, and another option being that that part of, up by the number 2, that part of California.
Yeah.
That to cover those maps. And I think that that might be of interest to California BLM also. So
I think the answer is yes,
yeah.
Send money.
Yes, yes, send money.
And I want to reiterate something that both speakers mentioned, and that is if you have an area, you know, everybody has places they like and they work, and you have additional data, that additional data can provide additional inference. For example, the presence of beavers will allow them to identify something as a beaver dam.
So what is the best way to get that data to Elaine? I had that question.
Yeah, let me pull up Elaine's last slide here where she had her address, and then people can call or email their information to Elaine, right?
Yes, I'm pretty good at responding.
Except they're going to be in the field this next week around Reno. Do we have another question, Liz?
Yep, we have one final question, and that is there a classification schema recommended for mapping wetlands and riparian for sage-grouse purposes? And also, are there any quality classifications, example being good, fair, poor, that should be used?
Well, really we stick to the national standards for wetland mapping, which is the Coordin classification system. And like we kind of got to with that Masic Meadow issue, that it may not actually encompass all sage-grouse critical habitat with our mapping, but hopefully we capture the majority of it. And if people are interested in learning more about the wetland mapping process and using our system, if you actually Google wetland mapping training, the very first thing that will pop up will be a set of 5 training modules. They're online training modules that I developed a few years ago that walk you through the whole process of creating data to meet national standards. I hope that answered that.
Well, thanks, everyone. I want to remind you that this webinar has been recorded, and it will be up on the Great Basin Landscape Conservation Cooperative's website. So you'll be able to go view it there shortly. And if you have any questions or comments about data or the presentation, please do contact Elaine, and she'll pass them on to her crew here and get you back an answer and or incorporate your data into their classification and analyses. Thank you very much, everybody.
Thank you. Thanks, Todd.